Thank you and good morning. It's an honor to be here. I'm looking forward to this. I'm looking forward to this talk specifically. This is an area that I think is an emerging area for us as professionals. I think it's an area that's going to be transformative. It is going to change the way we look at buildings. It's going to change the way the buildings behave. And I think it's going to open up some new opportunities for us. So I'm going to take a kind of a broad view of this topic. There'll be plenty of time at the end for questions and answers. Well, certainly the questions, I'm certainly hopeful that I'll have the answers for you as well. So with that said, let's blaze forward. Here's what I'm going to try and accomplish in our talk this morning. We're going to take a little look at the future of HVAC standards and codes. There's some changes there that is going to impact this whole topic. We're going to look at some of the current trends in IAQ and building comfort and how that applies to building efficiencies. And as we all know, that's been kind of the tug and the pull between those. How do you get to good energy efficiency and at the same time provide high quality comfort and a healthy building? And then finally, I'm going to look into my crystal ball a little bit and try and predict where we're going to be in maybe the next 5 years or 10 years. And again, try and focus on where are there opportunities for us in this industry. So what is our future? Speaking of my crystal ball, what can we expect in the near term? Well, I think you're going to see standards and codes and the other design data within our industry continue its movement towards net zero. It is, I think, going to be the standard that we're going to be designing to in a short period of time, and I've got some evidence, I think, towards that. There's going to be a continued demand for healthy and comfortable space. And the reason for this is because of some new research that's going on in terms of what healthy space means to us as human beings, not just in terms of our overall health, but also productivity. Now there are some issues, there are some research out there on making buildings more productive as well as more healthy, but I think that's going to be far more pronounced. And then finally, there's a consolidation of codes that's going on in our industry. One of the big problems we face, and certainly the practicing professionals in the room know this, that right now our codes and our standards are very fragmented. Okay? There isn't a lot of consensus because you can pick from so many different standards on indoor air quality or building efficiency. And so what I think we're going to see is a consolidation that'll make our life a lot easier. Let's start talking about codes and standards a little bit. One of the more common ones is LEED, Leadership in Energy and Environmental and Efficiency Design. And as many of you know, they came out with a new standard recently, their version 4, which was much awaited. It's a new platform. Okay, they have gone away from this fragmented multi-platform process now where every country, United States, Canada, Kuwait, et cetera, uses the exact same platform. But each country then can go in and generate some optional compliance paths and thus make LEED a local document, which is really important. Now, because we all have the same platform within LEED, all of us then are on the same track, and this is the track that LEED has pointed out to us. So as you see here, we're about at this point with LEED version 4, and this is where we're aiming for here, zero impact. That is exactly what the green building councils around the world want to achieve with this LEED process. They want to get our buildings to zero impact. We're quite a ways away yet, but we're obviously on that path to create that kind of building. And so LEED is part of the process that's pushing us in that direction. ASHRAE is doing the exact same thing. I'm sure most people in this room are familiar with our standards on building efficiency and indoor air quality. This is 90.1, energy efficiency design of commercial buildings. 90.2, and I'm very, very proud of this. We have a 90.2 for Kuwait that we did here recently. And these are our energy efficiency standards that we use for both commercial and residential construction. They are continuous improvement standards. That is, say 90.1 comes out every third year. We are getting ready to republish that document at the end of this year. Hopefully it'll be out around October or November. And in there you will find that we are pushing that envelope out. We are raising that bar just like LEED is doing. So you can find this graph on the ASHRAE website, and this is really the evolution of the 90.1 document. Over time, you can see how we started out here in 97 and how we have a continuous dropping of the energy use in a building based on 90.1. And I can tell you right now, 2016 version, as I mentioned, is imminent. It's going to be out at the end of this year. It is going to be the same thing. We're going to continue to drive those values lower and lower to help our industry get to a net zero impact. And so these are a couple of the main pushes that we see within the industry. Now I wanted to show you this graph as well too. Dr. Adnan Shahib, did I say that? Shahib Ainin? Yes. If you listen to his speech in the first keynote speech, I was interested to note he used exactly the same source that I used in my. The only difference between us is that he used data on carbon and I used data on energy, but both of us are telling exactly the same story. Exactly the same story. Energy use on this planet is going to increase. Carbon in this planet will increase. And it is going to increase most dramatically in the non-developed economies, because that's where the population growth is going to be. So it doesn't make any difference whether you look at his data from a carbon standpoint or my data from an energy standpoint. We're telling the same story. This is an issue that has to be addressed by our planet. It has to be addressed by us primarily. And that was the other great point that he made. If you look at the data on where this energy is being used, the majority of it is being used inside our buildings. And that's why every single person in this room is so important. It's why our industry is so important. It's because we have to drive the solution. This planet needs us, our communities need us, the environment needs us, and so we have a heavy responsibility in front of us to tackle this. He also talked about some other issues with COP21, which I agreed with as well. That's much the same process. One of the issues that we have with smart buildings, HVAC strategies and the like, is, as I mentioned before, we've got this pull and this tug going each way all the time. We want our rooms comfortable, right? We want our buildings healthy, and at the same time we want to lower energy. But so often one strategy that increases indoor air quality, like ventilation for example, has the unfortunate side effect of increasing, or can increase, energy use. So it seems like there's this balancing act that we're going on. This is I chose this graph because this is from where I live. I was born and raised in Nebraska in the United States, a very rural agricultural state. And as you can see, it's a somewhat cold state because we have quite a bit of heating there. The same data, if you went to a European, a more northern climate, you see that there's a little shift. This is actually from southern Europe. So you see a shift, more space cooling, much less space heating. And then finally, if you were to look at the data from Kuwait, you would find in Kuwait approximately 65% of the energy use in buildings in Kuwait is used for air conditioning. Okay, so it is. Most of the energy use in a building is driven towards comfort and IAQ. So the three topics, when you start talking about a smart building, when you start talking about HVAC strategies, first thing we have to keep in mind is those topics are all tied together. And so we're going to have to figure out how to address them together. How do we get all of those to flow together to create an integrated type of approach? So it's not terribly surprising then as we look at some of the standards and codes that I've mentioned. They are weighted towards energy use. Certainly LEED version 4 is a good example of that. And that kind of drives the equation and causes us then sometimes to forget what a smart building is really going to do in terms of indoor air quality and human comfort. I also mentioned that I think all of us are going to see a consolidation of codes in our future, which I think is good news. It's going to make it easier for the designers in the room to design. I'm a contractor. Okay, so I came out of the contracting industry. It's going to be a lot easier for us to build buildings. Here's a great example that is going on with ASHRAE. ASHRAE has signed a contract with the International Green Construction Code, and we are going to consolidate our standard 189.1 on high performance, design of high performance green buildings, and we are going to consolidate that into the International Green Construction Code. So there'll be one document. Instead of one referencing the other, it'll be integrated and it'll be whole. That, we think, will be available to you in 2018. That's our goal. But I think that is exactly the kind of thing that you're going to be seeing more and more of in the future. And as I said before, I think that's going to be a really good thing for us. So here's some of the issues that we've got going on with standards and codes. Number one, we're running out of physics. Okay? We're trying to move this planet to a more sustainable position, and we're trying to do so with building efficiency. But ladies and gentlemen, there's only so much insulation you can put in the roof, and then it doesn't return. There is only so much insulation you can put in the walls. There is only so much improvement you can do in glazing before you run out of physics. So we're going to have to do something else if we're really going to get to this point of net zero buildings. There's an inevitable trade-off between energy efficiency, energy consumption, IAQ, and thermal comfort. Talked about that. Comfort and IAQ are difficult to quantify, much more difficult than energy efficiency. And that's one of the reasons that, quite frankly, the codes and standards are weighted towards energy efficiency because, yeah, from a physics standpoint, it's easier to measure and it's easier to deal with. We're seeing some changes in comfort and indoor air quality research, and I'm going to talk about that a little bit later, but it is still much more difficult for us to deal with. And then finally, here's the question, and here's the topic of this talk. Can we optimize energy efficiency and building comfort and indoor air quality all at the same time. Is that possible? If it is possible, how's that going to be done? If it is going to be done, what's that mean to you? How can you use that information then to make your firm's better, you more productive, teach your classes in a more, at a higher level, whatever it is that you do in this industry, how can we use this information to make us all better? Now I'm gonna make another prediction. Okay, I told you this is kind of a futuristic look at our industry and some of the things going on. Here's the thing that I think, 3 things that are going to transform your lives. Number 1, there's going to be a dramatic change in technology coming up shortly. And ladies and gentlemen, I think it's going to be breathtaking. The changes that we're going to see in both computer hardware, computer software, what that hardware and software can do and what it means to us. That will drive this industry to a more integrated design basis. Okay, we talk about integrated design now, but we don't really do integrated design well. And this new technology, I think, is going to allow us to finally grasp that opportunity and do something with it. And here's what it is we're going to be doing. It's building performance. I think in a very short period of time, our industry will change, and instead of relying on a prescriptive basis of designing and constructing buildings, we're going to move towards a basis where buildings are designed and constructed on a performance basis. That's going to open up all sorts of new doors for us. That, I think, is the path that we need to take in order to get to these new net zero buildings. So, what technology am I talking about? Here's some of my ideas. Building information modeling's been out there for a while. That is not a new product. What the new product is going to do in the future is amazing. We've already using it on what we call 5D, okay? Regular 3Ds plus scheduling plus costing. They're talking about modifying building information modeling up to 9D. So it is doing its own design. It is doing its own estimating. It is taking this data and creating everything from purchase orders to manpower loading charts to every concept of the cradle to grave aspect of a building, including maintenance and operation. And to me, maintenance and operation has been the weak link that we've had in our industry. We have many design engineers in the room. We know how to design high-performance building. And I know we have contractors in the room. We know how to build a high-performance building. But it doesn't make any difference how you design or build a building if the owner of that building doesn't make a commitment to operate and maintain the building to high-performance standards. And that's been a part of our problem. This new software, this new technology, and it's probably still a couple, 3 years downstream yet, but once it gets here, it is going to be remarkable about what it's going to be able to do. One of the things that it's going to be able to do is it will have embedded into it augmented reality. It's not going to be just a 3D program that will model a building. It will model a building and it will play what if you want to make this change. It will create a model that you can project. And they have got now safety glasses that you can put on, and the BIM model will be projected through your safety glasses, and as the picture on the screen demonstrates, it will put out there whatever it is you have designed right on the job site, so you can see it in real time. They have created a backhoe with a windscreen on it, and the windscreen is BIM embedded. So now the operator of the backhoe can call up the BIM model and project the building design as it is out onto the site, and they can start doing their earth moving work based upon the latest design. This augmented reality process is amazing. I've seen some of it. I've seen some of the prototypes or the beta versions. I saw one here just recently. It was all done through an iPad. And so this gentleman said, okay, take this piece of paper, 8.5 by 11 piece of paper, and he said, watch this, and he hit a button on his iPad, and out of that 8.5 by 11 sheet of paper emerged this steel structure of, it's like a 3-story building. Came right out of the page with nothing but an iPad. And he said, I said, wow, that's cool. And he said, now move the paper. So I moved the paper, and the building was anchored to the paper. It moved as I moved the paper. And I thought, wow, that really is cool. And he said, take a harder look at what you're doing there. And so I moved the paper, and I looked, and if I looked closely, I could see the steel superstructure change its size as I moved the paper. And I'm looking at that, and I thought, well, what's going on there? And then it suddenly dawned on me, I'm moving this paper around, and the paper knows which way is north, and the model knows how many windows I have in the building, and it has recalculated the solar load every time I have moved that paper. And apparently the HVAC equipment was on the roof, and so when I moved that paper to increase the solar load, it increased the structural steel just like that. And I'm sitting there with my mouth open, and I'm going, wow, is that cool? And that's the kind of thing that we're seeing come down the pike. And it's going to change other industries as well. Just to show you I am really a college professor, it is pop quiz time. Who knows what that is? I'm talking about the object here on the left. Anybody want to guess what that is? It is a helmet. Whose helmet is it? What's that? It's a fireman's helmet. That is a fireman's helmet, and the shield is embedded with BIM. And now, here's the important thing. What kills more firefighters, smoke or fire? Smoke is correct. More firefighters die because of smoke than fire. And so what they've done is they've taken a fireman's helmet, put a shield on it, embedded BIM, and as long as that building has a BIM model, that firefighter can go into that building can be filled with smoke, and yet they can see exactly what's in front of them, thus getting to the people in the building quicker, saving more lives, and at the same time saving their lives. So, and this is kind of new stuff coming on that's going to be really transformative. Let me show you another one that I thought was really amazing. And this gets us to the point of big data, or the Internet of Things. Those are two things that you hear a lot about. And those are obviously emerging trends that are going to have a big impact on us too. Big data refers to the fact that now in a building we can generate data points by the hundreds of millions. Okay, which is great, but what do you do with that? Well, the Internet of Things then talks about everything being connected. Okay, we've got a cloud, we've got the internet. All of a sudden that projector can talk to the screen, can talk to my computer, lights can talk to the HVAC system. We can get everything speaking together. And it's just exploding. I think this graph is really telling at how fast we are becoming connected. In just 2003, we had less than one connection per person on this planet. We are now at 2015, and we are at almost 4 connections per person. By the time we get to 2020, which is just 4 years off, they're expecting 6 or 50 billion connections for our population. I'm talking worldwide. Now that's an explosion of connection. That's an explosion of connection. And it will then help us get to a smart building with the same kind of technologies I've been talking about with BIM. This is going to get us to a smart building where all the various components of a building can talk to each other. And so for the first time, we're going to be able to do things like balance our electrical grids. We are going to balance the energy both from a site standpoint and from a source standpoint. That is going to be transformative for this planet. And what's so exciting to me is all of us in this room are a part of that new tomorrow, that new process that, gosh, I'm excited. I mean, the technology that I'm seeing come down the pike is pretty much amazing on many different levels. I thought of one more that I'm just going to tell you. I was reading some research the other day. There's a gentleman in California that has figured out a way to 3D print a home, 2-story home, 22 hours. 3D print technology. There's a project going on right now in Amsterdam. 3D print a 24-foot steel cantilevered bridge. 2 months. I mean, this is an amazing set of technology that's coming down towards us. And think, we have such a housing problem worldwide. What if we could 3D print homes in 22 hours? How would that change this planet? Think about that for a second. Awesome. So this new technology, and by the way, I just talked about a few things that are going on our planet. Now we can take that technology and we can drive it to create truly integrated design. So for the first time, engineers, architects, contractors, manufacturers, owners, everybody is working together off the same database to create a truly integrated building. We need to have a truly integrated building if we're going to get to this concept of net zero. It's the only way to get there because of, quite frankly, the lack of physics that will hamper us. Once we get to integrated design, that's going to be a new world for us too. I think, again, my background is in contracting, and so I'm used to working with architects and engineers. You got these little boxes, and you have to stay in your box, and you got these little arrows, and in truly integrated design, all the boxes go away. All the boxes go away. And now all you have all these arrows going every which way because all of us, it doesn't make any difference what discipline you are representing today, all of us have a duty and a responsibility to get that building to high performance. That's why we need integrated design if we're really going to take the steps that are necessary. Now, what is ASHRAE doing about? ASHRAE absolutely believes that technology is going to drive us to integrated design, and integrated design is going to drive us towards building performance. So you pick up some of our products, some of our newer products, like the Advanced Energy Design Guides, which we're extremely proud of, 189.1, which we're extremely proud of. You notice that our sections in there now allowing for integrated design paths instead of the prescriptive paths. You're going to see more of that as we transform our standards and our guidelines and our codes to an integrated approach. You're also going to see our standards move towards building performance. Now, many of you also work in Europe. Europe is much more performance-oriented than the United States, and yet we recognize that that's our future. And so as you pick up 90.1 at the end of this year, you're going to see a much more fully developed building performance approach on it. And this building performance is going to focus on how do we really do this HVAC thing and do building comfort and indoor air quality simultaneously? How do you optimize all that? So where are we headed? Where is the industry going? My look at the future, I think we're on the cusp, ladies and gentlemen, of a new golden age in our industry. I really, truly believe that. I can't tell you how excited I am about our industry, because I think we are going to be able to do things we have not been able to do before for the benefit of this planet and its environment. So how do we do this? Okay, so let's look at the future a little bit about this optimization process. How are we going to use everything I've talked about now to get us to a healthy environment, a comfortable environment at the lowest possible consumption of energy? Well, here's some of the things we're using currently. ASHRAE is involved in this process through our standard 55 and the old 80-20 rule. You know, we're aiming for 80% satisfaction. Another way of saying that, it's only 20% of the people are dissatisfied. Does that sound good? Or that just kind of always hit me wrong. Wow, 20% of the people don't like my design, so that's satisfactory. We can do better. ASHRAE standard 62.1 on ventilation. Here currently, basically we're using a lot of dilution, and I think that'll change. And then 90.1 that I've discussed already. So here's some things that we know for sure, and we've had some excellent breakout sessions on indoor air quality and human comfort. And we know that the more individual control you can give somebody, the more apt they are to be satisfied, and all of a sudden you can get beyond that 80-20 rule. Zoning is also an issue there, to the fact that you can create more zones, you can create more comfort. Now, as a contractor, I know more individual control, better zoning, that generally means more money, and so now we have economics rearing its head into this conversation. IAQ is enhanced through contamination control. Really, we're using now elimination, which is our number one, dilution and filtration. I love this quote. This is from Max van Pettenkofer. He was a German physician in the 1840s. And by the way, he's still used in medical schools around the world. This is the gentleman that figured out why there was cholera in Germany and figured out how to resolve it. This is one of his more famous quotes: if there's a pile of manure in a space, do not try to remove the odor by ventilation. Remove the pile of manure. Okay, I think that's a profound statement. And it is a profound statement because we know that if we don't put the contaminants in our building, we don't have to remove them. And so there's new technologies out there, and everything from low-voc paints to low-voc sealants, various other things that keep those pollutants out of our space. This is still, after 200 some years, this is still the best strategy that we can use, and certainly the most economical. A couple other strategies that we use quite a bit: dedicated outside air systems and demand control ventilation. I think we're familiar with those, but those are technologies that we've been using now for a few years, and they work. They each have their own limitations, obviously, but they are solutions that we are currently using. So how can we use this stuff that I've just shown you, the current stuff, how do we adapt that to go to that next level? How do we make this better? Okay? Part of it is going back to this concept of big data and the Internet of Things and technology. Very shortly, we're going to have the ability to do sensing and controlling at a level not seen before, to create both better comfort, healthier buildings, and at the same time drive down energy consumption. An example, this happens to be a picture of ASHRAE's headquarters in Atlanta, Georgia. We do real-time sensing at our building, and we look at a whole host of data points, including carbon dioxide, volatile organic compounds, carbon monoxide, humidity, temperature, energy consumption, and it is measuring both pollutants and human comfort at the same time. Now, this generates millions of data points, but we have got or are developing the technology to know how to use that data point to make the building more adaptive. Here's an example of what that looks like. By collecting this data, we can send it to various controllers and have the controllers then modify the system to optimize each of those three levels. So this is a rudimentary system. We're going to soon have something much, much better available to our industry, but it is the right path, I think, in order to optimize all three. The other thing this does for us is it gives us some points where we can make better decisions. Here's a real-time sensing graph that is showing a spike, a significant spike, at a certain point of the day that immediately goes away. And so you can look at that and say, well, what's going on there? Well, that was the cleaning crew. And the cleaning crew was using some fairly noxious chemicals to clean the building that were bringing pollutants into the space. So now we're back to Max von Pettenkofer and his don't put it in the building concept. This is an easy way to make a big difference in a fairly short period of time. Here's a product that's available that I thought was fascinating. I've scrubbed out all of the names off this, but this is something you can buy. You can get on the internet and buy this. It's software that you incorporate into your temperature control system, and it allows people with an app on their phone, which is also a part of our future, to vote for 10 minutes of heating or 10 minutes of cooling for your own individual space, wherever you are. It's GPS driven, so it knows where you are. So if you're in this room, you can hit your app and say, hey, it's too cold in this room. I want a little bit more warmth in this room. And this software then will respond, which, is okay. And I'm sure you're sitting there going, boy, I don't want the guy in the office next to me with that app, because some people have widely divergent views of human comfort, but this is what makes this different, I think. Look at this. This software not only records this, but uses algorithms then to create a new program as human beings vote. So as the people in that building vote for more cold air or more warm air, it is creating its own logic network so that where there are no votes, it allows the deadband to expand, and where there are lots of votes, it narrows the deadband. Ladies and gentlemen, this software actually thinks. And once it starts thinking, then it starts predicting. And so here's a building that's on the verge of being a smart building that's thinking about how you behave and why you behave the way you behave, and then starts anticipating your behavior and adjusting the temperature and the energy consumption to match that. That, to me, is a breathtaking use of technology. Here's one more. This is an adaptation that came by recently from a molecular cleaning product. It's an absorbent that we use in the space industry. Now, it was long thought that this particular process was too expensive ever to be used in a building. Well, there's been a change in technology here, and this change in technology comes to us from physicists, and so they have now figured out a way of regenerating these sorbents on a much more economic level, and so all of a sudden you can now ultra clean out this air, and they use it as a side stream kind of filter, so you're not cleaning the whole airstream, you're only cleaning 10 or 15% of it, and allows you to come up with a much cleaner airstream inside the building with a much reduced level of outside air. So now you are really starting to optimize both sides of that equation. This is some new, and so keep that in the back of your mind. Here's some more new research that this is about 3 or 4 weeks old, so this is brand new. This is some research done in South America, a really fascinating set of research done by a biologist, of all things, and he was doing some research on bacteria levels in homes. And he wanted to look at 2 different types of homes. The homes we live in, right, which are sealed and conditioned. And then he wanted to look at what he called traditional homes that were not sealed and not conditioned. And for that, he went to Brazil and looked at traditional homes there, many of whom, like this home in the picture, doesn't even have walls. Okay, so this is high ventilation rates, no walls, and he compared the two. And what he found was fascinating. He found that the bacteria levels and the type of bacteria in our homes that are sealed and conditioned was much different than the bacteria types he found in the homes that were not sealed. Then he made a hypothesis. He said, you know what, I keep reading around the world that our children have higher incidence of respiratory problems like asthma. And his hypothesis is, well, is our children, the fact that our children have more asthma, a function of the bacteria we're putting in the homes in which they're living? Answer to that question is, we don't know. This is brand new research, but it opens up a whole new line of thought that we hadn't considered before. And it's a line of thought that may change the way we look at indoor air quality, may change the way we look at ventilation rates. So this is a research conference, and I've sat in all of the breakouts and fascinating research going on out there. This is the kind of thing that's going to change our industry. Now, I've talked about all the good things. Now I'm going to talk about one of the bad things about all of the kind of technology that I've been talking about and Internet of Things and the big data and all that. And here's the downside, cybersecurity. The more Internet of Things that you have, the more portals you have, the bigger the opportunity of people of bad intent getting into your building. And it is a serious, serious problem in our industry. Probably one of the worst cases I can think of comes from the United States. The Target stores, large department stores, they had a break-in, and the break-in came through a person from our industry, a mechanical contractor, I'm sorry to say, and some people got into the Target system and stole 3 million credit cards. And you're probably sitting there thinking, oh, well, they got in through the temperature control system. They didn't. They got in through the accounting system. I mean, it's a new world. And so this has to be a part of our thinking too. Cybersecurity is going to be one of the drivers of our industry. So here's where we're going, okay? So you think about smart buildings. Here's what I'm thinking when I think smart buildings. I'm talking about buildings that are self-diagnosing, self-healing, self-reporting, self-commissioning, and to some extent, self-designing. I think that's all part of our future. It's going to be a great future. We can do this, right? We can do this. We can optimize comfort, indoor air quality, and energy simultaneously. So, thank you very much. I appreciate it. I see we have some time left for some questions.
Yes. Thank you very much.